Here we're going to measure the truth table of a JK flip-flop. I have over here two chips. Each chip, 74112, has two flip-flops in it. I've powered the chip by 5 volts and ground. Let's turn it on here. And I'm going to put into the clock a 1 hertz signal from the function generator. Let me turn that on. Okay, so there's about 1 hertz. So this red LED shows the input to the clock input of the flip-flop. The green light is the output of the flip-flop, Q. And these two red LEDs over here will show when J or K is 5 volts. When they're dark like that, they're both grounded. Okay, so that's the first step, is they're both grounded. Now I'll take and put 5 volts in on J. So J has 5 volts, K is grounded. You can see the input clock and the output. Now I'll ground J and put 5 volts in on K. And you can see the output there. And next I'll put 5 volts on both J and K. So you can see the clock coming in, the output out there, and this is what you'll describe in your report. So here's the circuit for binary counter, and we're using 3 flip-flops. In each of these chips there are 2 flip-flops. Each one of these chips is a 74112 and has 2 flip-flops. So I'm using the first 2 flip-flops in the top chip and the first flip-flop in the bottom chip here. So I've taken the output of the pulse generator, which is putting on TTL pulses at about 1 hertz. I'm putting that into the clock input of the first flip-flop, and you can see that this LED is also on that clock input, so you can see that it's about 1 hertz. Then I've taken the output of the first flip-flop and put it into the clock of the second flip-flop, and then I've taken the output of the second flip-flop and put it into the clock of the third flip-flop. And then I've taken the outputs, the 3 Q outputs of the 3 flip-flops, and I've attached them with current limiting resistors to these 3 LEDs down here. So the bottom one is the least significant bit, call it A, and the top one is the most significant bit, call it C, and the middle one is B. So you can see it counts from 0 on up. Here's a circuit that is designed to drive a 7-segment display here in blue. We're using the same using the same 2 chips up here. We're using the 3 flip-flops that we used before, but I've added 1 more digit here by using this least significant bit as the output of the function generator. And this is the function generator, Q1, Q2, Q3. So this is the least significant bit, and up here at the top is the most significant bit. You can see I've added current limiting resistors for the red LEDs and for every segment of the blue LED. You can see that it counts much higher than the 7.